I'm Rushil. I'm going to be presenting Mac. This is like a prompt of we intended intended to build like a constitution learner, but you'll see we ended up building a prompt optimizer by happenstance. So this is Mac. This is done with me, Gautam. So we don't have like 80 authors like the last paper. It's for you, and you won't probably be a co-author if you just like make a small review. It's not possible. I'm happy to do it. We just have four guys, and then Francesco from DeepMind, Propner Zukas. He's like a price security person. I did my security by the way, but yeah, this is Mac. Okay, so with the show of hands, how many of you guys know about like constitutional AI, Anthropic? There you go. So a lot of people. Cool. So yeah, I mean, constitutional AI essentially what this is doing is, I mean, you wanna look at, okay, I have a bunch of truths, right? You don't tell people how to build a bomb, right? And we just like give it to an agent, and then the agent doesn't tell how to build. So that's constitutional AI. In fact, turns out your Claude Code agent has a constitution. Think about with like a bunch of rules that the agent follows. Super useful. A lot of people do this now. Okay, but then the key question is, uh, building this constitution is super hard. Right? So if you look at Anthropic's work, in fact, I met them at ITO, not for Mac, from another paper. Mac was projected at ITO. So yeah, but I met the Anthropic people, and then the same question. Hey, I mean, where do these constitutions come from? So it turns out these big companies will have like a team internally, like experts that put down a constitution. In fact, couple of like compliance people. So do this back and forth, and then you come up with the constitution, and then you just roll it out. And these are useful because you can like use it for reward. So it's constitution is super useful. Apart from like the safety set stuff that I mentioned to you guys. So yeah, I mean, Anthropic says everyone this is out there, building this constitution is super hard. So the idea was, okay, what if using like supervised data, like some data annotation, we just learn these constitution. Learning constitution would be, okay, we expose some data to this algorithm, and then it learns these bunch of rules for you. So that was where we started essentially with math. You know. So yeah, this was the purpose. Essentially, the idea was, okay, let's learn these rules, let's say through operations like adding rules, and then you just like put them in the agent, and then you like supervise the agent, right? But what ended up happening was we realized, okay, this is analog optimization. Because essentially what we're doing is we're taking this bunch of rules, we're putting them into an agent, and then the agent's doing something, right? They're supervising the agent, or we're getting like high performance. But if you look at what prompt optimization does, that's a big silver. You start with an initial variant of a prompt, and when you said find a different variant, you put that into the prompt, you just like get high performance, right? Like the first talk, essentially they had the harness part, right? So you're learning a prompt essentially. So we realized, okay, this is analogous. Turns out learning these rules is similar to learning prompts. So we might be building a prompt optimizer, right? Yeah. But there are fundamentalities. I mean, how many of you guys are like use GEPA or IT the classical prompt optimizers? So a bunch of people. There's a bunch of issues with these things, right? I mean, turns out, by the way, GEPA's a Blakshay who created GEPA as a good friend. We went to the same undergrad school, so no hard feelings. But GEPA issues. I mean, first of all, uh, prompts are insanely big. I mean, it's like insanely huge, verbose prompts. Like, if you have an internal team, let's say a legal team or like an HR team, you wanna at least get their go ahead on prompts, right? Before you deploy a system for, let's say, compliance. You can show these prompts to them because this is the nature of their optimization process, right? You do these full redirects, your prompt changes at the iteration. In fact, if I show you what this that doing, they're doing something like, okay, I've got a big set of prompts, and then I was like, okay, this is my burrito set. I change one prompt, rewrite, change, see how well it performs, and then based upon the performance improvement or decrease, I decide if I want to add this in my set that I want to optimize, right? Now think about it. No one in the process, I'm actually thinking about what's the quality of this prompt? Is it like huge, like small, or is it like, in fact, turns out the agents to perform better on the huge prompts. This is by the nature of like these errors. So they become super difficult to audit. So realize this is not probably the way to go about it. If you can do rules, it's much better, right? And then think about it. prompts keep growing, auditability grows, but also somewhere down the line, you can like spend 100K tokens on a prompt, you will have the performance loss as well. So we realize like prompt optimization might be a better way to, sorry, constant learning might be a better way to solve this, right? Yeah. So that's what we do. Essentially, the idea is to be straightforward. You have this core agent. That's the annotator agent. We call it an annotator because like we started off with a PI classification task, a private token, just a candidate. But it could be generic agent, any agent out there, right? Think about classification or some other task or like storytelling, whatever. It's fine, legal. So it's an agent, and essentially what you're doing is the agent will go out in the wild, right? It will make some errors, right? So let's say you throw a batch of like input and output, the agent makes some errors, right? So these errors with them, let's say go to a distilling agent. The distilling agent says, okay, uh, based upon what constitution or a bunch of rules that the agent had already, what update should I make now? Okay. And the cool part is, as soon as that decision agent makes this choice, it's going to output its reasoning for doing it. Because this is also my, again, criticism for the other prompt optimizers. They'll run the genetic algorithm, right? So you keep updating, but then think about it. I'm on my terminal, I'm seeing the prompt optimization. For me, is fully black box. That I have no idea how this evolution is happening, right? Right? I'm nowhere in the loop. But this could be a high stakes system. I should be able to supervise my prompt optimizer, right? So what we did was, as I said, this decision agent is gonna outputs like reasoning that hey, I feel given the state of my constitution now, I should either edit a rule, I should either add a rule or remove a rule. So this goes to the human based upon the choice we invoke the other agent. So let's say you invoke the editor or you invoke the rule creator, and then essentially they mainly update to the constitution poorly. So let's say you invoke the creator is gonna add the rule, the editor is gonna let's say edit the rule, and then you'll have this proposed update to the constitution. This part is analogous to the Pareto step, right? Where you're like making an update to a constitution. But think about the atom of the update. Did not perform a rewrite here. All you are doing is seeing your constitution and saying, okay, where do I make this surgical update? Do I add a rule, like edit a rule, right? And the other agents also come with the explanation as to why they name this twice, right? So they will do that. We'll have a proposed update to the constitution, then just check, oh, well, how's my performance on my files, right? Based upon that, you decide if you want to persist the constitution or not, right? So that's the core optimization loop in general, because you're using these aliens. It's explainable, trustworthy. Yeah, that's the point. Okay. Yeah. So a little bit formalization. I think essential since happy in the optimization set is pretty straightforward. Uh, you just want to learn C. That's the set of rules. So think about the space of all rules out there. You want to learn the optimal set of rules, right? That's your constitution, right? And essentially what's happening as part of the agent is the agent under fixed weights. Now this is also super important. You don't touch the weights at all. The agent stays constant, right? I come to why I think it's the way to go about self-improvement. Uh, but yeah, use like Opus 4.7, right? So 60 small, completely black box. You pass in your input, you pass in the constitution, you get some output, right? And then you have this verifiable task metric. Right? So think about F1 score or accuracy or whatever. You can define your own metric. Uh, the idea is okay, I want to essentially optimize to find the best constitution that gives me empirically the best score over a subset. That's my optimization objective. And the way you can do it is super straightforward. You're making CCAP. It's like a small update to the constitution. So you have this delta change, right? You take that into account, you make that update to the constitution, you decide what step to make, like add, edit, or move. And then based upon, hey, did my verifiable metric, which could be F1 or accuracy or anything, if it improved, let's say above a delta quantity, do I want to persist this change or not? Super straightforward. Now, I did a bit actually try a bunch of stuff. Like we did like a genetic loop. Did something analogous to like just getting descent, right? And then you chose, we decided, okay, one of go with something that's ubiquitous. Like everyone's like touched a trading algorithm like this, right? This is your epoch bad stuff. Because the idea was you want to keep it like super explainable, easy to understand. The human should be part of the optimization process itself. Nothing's black boxed. Why? Because this is a high stake system, right? Every update should come with human oversight. The human should be able to check it essentially, right? That's why we went with the simplest approach. This is actually an old one. So this got rejected at SCML. Uh, this part of the process happens all the time. And then we submitted it to NeurX. So we have updated the algorithm in general. But yeah, this isn't telling you the approach. It's a more like focus for private tokens, but the Q draft is like super general. So you use it for like anything, And that's how we write the paper though. This is legit PIF focus, like private token focus. Because I work at Paris Institute, can you want to optimize or optimization person or I don't know. So yeah, but the idea is straightforward. As I said, you do epochs in batches. Because turns out that's what people understand. That's what people are used to doing, right? Let's move away from this genetic stuff. Okay, but you do that, and essentially, as part of the first batch, you'll make some error, right? You find out, okay, you have some like a function. Think about this. This, by the way, comes to users. So users will provide to you how you find this verifiable metric based upon the model is output. For example, for private information detection, it could be super simple. It could be something like, okay, there's like a span of X. I found out this has private. The model said this was private, so you lose. And then you pick it into account, you can calculate F1 or something else. That depends upon the use case. You just write some code that calculates this. That goes there, right? As soon as you do that, it goes to decision agent. The decision agent could look at the error, to look at the state of the constitution. It'll produce a reasoning and the choice. The choice says, okay, do I go towards add or remove? Based upon that choice, you invoke the other agents, right? Uh, it could be the editor or the creator, or you can just like remove the rule in general. Just keep doing this. At the end, based upon your verifiable metric, you'll get this optimal constitution, right? You just put it out. That's the one that you use in production, right? You just show it to your stakeholders. Let's say now working in a company, you say, hey, this is a bunch of rules that I think you should use to supervise our agent. And if they give you the go ahead, you deploy, right? That's the premise. Yeah. Okay, so we have three different variants because we realize there's a lot of things we didn't do here, right? Because you're essentially using these agents uh, to figure out how to make these surgical edits to your constitution. So we realize, what if there's like a way to find or update the agent at being better at this task? So we looked at tracing. We saw tracer from a 14B model, a 120B model, and the super small models like 1 week TV. And turns out the super small models like couldn't even grasp the task itself. In general, the task of the decision agent is like high capacity. You want to check based upon the state of configuration. Hey, where should I run X, right? The edit we create is similar, but this decision was super difficult, right? So the small models, for example, will keep on like adding code every time. That probably edit was the right choice. But the cool part was we were like collecting the full reasoning traces, right? So we knew what these different models are reasoning and thinking about before making their choice. So we did a very small experiment. We like collected traces from the bigger model, and we already had to verify the metric. So we knew, okay, if an agent is doing a particular trace, what change in my verified metric is it leading to? Is the metric going up or going down? Right? I have this for each trace. So then I can use this as a metric to filter out for high quality traces, right? Like what decisions led to like high increase in my F1? I can do that. So we did that. We collected those traces and then just used essentially distillation setup to update the student model. And turns out this performs super well to an extent where if you like use traces from a 14D model, use it to update the 3D model, you can actually outperform GRTO or SFT, right? So this performs really well. Some loss curves essentially see loss curve for each agent. So essentially we like collect high quality traces for all the agents in the map pipeline and then use like this essentially distillation setup by selecting like high quality traces to update each agent in the pipeline. You know, so uh, all the agents benefit from this immensely, right? Especially the amplitude agent, is the core agent that we want to optimize, and this tells you sometimes when you want to use a smaller model or an agentic setup, just find high quality traces in SFT. You don't even need to like GRPO, right? Yeah. And then there's this other variants where essentially, okay, let's say you work on the private information detection space, right? Essentially, what you want to do is you want to identify these private spans. And turns out, let's say for healthcare documents, a lot of like super niche terminology, like some obscure disease name, right? So for tasks like that, an in-context learning setup works super well. Why? Because you expose documents and the private spans themselves to the agent and then understand, okay, hey, I want to like identify this particular disease name, right? So what VMAT does is it's like a very simple approach. You have this, let's say, ground truth set, right? At test time, you will essentially run out the agent. You will see what document you have received. You will run some sort of a retrieval setup and say, okay, in my like annotated set, is there a document close by or similar to what I received that I could use to essentially improve the formats? You run like a retrieval setup, you see some validity here, you put in the retrieved document, and you just like use it to like to the task itself. This also comes super well. But we didn't choose to like have this as the core contribution of the paper because this is now a departure from the trustworthy approach, right? Because at test time for each new document, you'll have, let's say, a different document comment. So this explainable or trustworthy aspect could be difficult. So therefore, we like, okay, this is a super cool experiment. The results are insane, but not part of the core paper in general. Okay. We will switch to the QA, but this is actually, I think, super cool and US is relevant to the talks we saw before. So yeah, one of the four criticisms for the first iteration was for Mac was, hey, we're doing like super specific private information detection stuff, right? Uh, this is not generalizable. What if I want to optimize for like some legal agent task or for like for QA or for a GSM AK, right? So what we realized was when you want to support a different downstream task, all we need to do is like update how the metrics work in the code and the prompt for the agents themselves. So this is what we do now. This is actually a core contribution of the new Lyrics paper. Essentially, you give your input outputs, you give your task metrics to the meta agent. The meta agent like essentially sets up the prompt for each of the agents, sets up the metric, and you're good to go. We support like everything out there. Okay, so this is over fact verification. Uh, on settings, we see the super high improvement. I mean, 26% up on two settings. I'm not giving you details how these look like, but it's actually using a different model for the meta agent than for the aggravation. Yeah. So other results, the step up, what is GEPA and MIPROV. So the dark green line here is MAC. This is for private information detection. Uh, for all settings across, at least for this private information detection task, we beat GEPA and MIPROV. And we're like super efficient because our prompts are 30% smaller, some validation loss curves. This is not analogous to what you would see in a machine learning setup because this is like prompt optimization, these random, you might see like gains up from the start and then stuff flattens out. It's not SGB, right? So it's like expected. And then the Mac Plus curves, as I said, turns out, I mean, so Mac Plus agents over validation will outperform GRTO and SFT. That's super cool. In fact, we work in the privacy space, right? So we don't even like fine tune on Illuminator. That's that he's essentially what we are doing is we're taking legal and healthcare and finance, taking traces, hypertraces from here and testing on legal, right? So it's like totally cross domain. But just by an agent, because now the agents understand, hey, this is how I optimize the agent as part of Mac. So you get the performance improvements, right? There is like no in-domain memorization privacy leakage stuff. And I should truly end and yeah, I'll take questions. Go ahead. So easy. Yeah.
I'm curious how to prevent the rule set load. Like, I'm imagining the F1
Yeah.
doesn't necessarily punish that. So I would imagine like a regular model, let's say a rule set proposal would be every unique quirk in the data set could be generated as a rule set. Yeah. The decider should aggregate it. But the simplest example I can think of is a human would say, "Do not teach how to harm other people." And from the data set, it could come out, teach how to make bombs, teach how to use lies and stuff. So how do you prevent the low?
Yeah, I mean, this is essentially going towards, hey, what even is like a high quality constitution? A high quality constitution is the one that generalizes, right? And turns out we observe stuff like this, for example, for private information detection, to say it'll be like, hey, remove all names that start with the letter N, just because that batch are like a bunch of samples later. But turns out, as for the automation process, you have checks in place to essentially make sure you're rewarded to not do stuff like this. For example, you will fail on the UL side. The listener didn't understand. Hey, it's not generalizing. So with time, you should find nodes that generalize. That's the point of the optimization. But this happens. We see it all the time.
Yeah. So where's the cost of that? Like in the
It has to be through VA. And then you have this validation check, right? When you want to persist the constitution. Well, let me show you. Right here. So if the rule don't generalize, you don't persist them. They will kill you. You will not have an entry fun, right? That's where the stuff like that comes into play. Hope that answers your question. Yep. Go ahead.
How are you evaluating these separate pages that you have? Can you talk a bit about?
Each evaluation of each agent. Yeah, so we actually have experiment in the paper. I don't have in the slides. But essentially when we did this like fine-tuning setup as part of Mark Plus, you wanted to see, okay, are these agents even improving on their own regard? Because you just have the loss curves here, right? So it turns out we'd be like a judge setup where you would run the base agent and the Mac Plus agent, and you just like check, hey, for this particular, because you have the traces collected, you know what the agent was exposed to. So you give that to the judge. Hey, for this particular scene, for this particular setup, is this agent doing a better choice with that one? We are the experiment. You should look up in the paper.
Oh, yeah. For the limited data,
Yeah.
when you are doing experiments,
This is super limited.
yeah. So how do you ensure that the model update may not be required?
Yeah.
We see what essentially within the framework.
Yeah.
Allow it to work with limited data. For example,
Yeah.
weak supervision.
Yeah, I mean, we are built for low data. For example, the experiments you will see in the paper is just 100 documents, you know?
Right.
Because the idea was, hey, if you use like a super big model, they can capture these learning signals from very limited data, and then you should be able to persist in the prompt for the smaller region, and it should work, and it does work. But then as part of like specifically optimizing for, let's say, limited data, we don't do that. The pipeline and the approach supports it. But because I'd say any prompt optimizer out there, we look at Gepa, Meeple, or Mac, all of them work decently well with limited data because you do automation in the prompt space. And that's my core argument why I do not think like the weight space update is like really the way to go. Because turns out for an enterprise use case, you can get by to 95% performance in just doing prompt optimization for that, right? So yeah, that's this supports less amount of data. Works pretty well with this. Yeah.
It seems like, especially when you were talking about the enterprise use case, yeah, a big topic of discussion right now is token costs.
Yeah.
The increase of rising of token costs.
Yeah.
I know that you said that this is pretty limited in terms of the current scope, and obviously with more time and I'm sure more resources, this would probably become even more in depth.
Right.
But I'm just kind of curious, what do you think? Where do you think this could impact the way that enterprises go and change how they think about
AI costs? Super cool question. Thanks for asking this. So it turns out I'm actually the founding engineer of this company called Agentite, certified properly from MIT. We do this like on a daily basis. 6 months I'm working on an enterprise project. Never even started as a review. Back as part of the lab in the UAE, they have like 1,000 details to play with. You don't get. But as part of this enterprise project, never you will turn on a G. Why? Because turns out these models are super powerful. Opus 4.7, GPT 5.5, super powerful. You take their needs, so do like a weekly core. You open up as a Cloudflare codex, and it's like persist these prompts in there, right? To persist these rules in the Excel, get you like 95%. Turns out, okay, you want to like fine tune a model, right? So what's the cost comparison on this? The cost comparison is, let's say, doing a lot on like say GPU assessment and hosting it. You'll pay like $1 or $2 for an EVA to do that, right? So Turns out if you use like Claude 4 or 4X for Mac or GitHub, go optimize prompts and the query agent with these APIs, on the long run, it's actually simpler and cheaper ways, right? Okay, you for the enterprise use case, you get like to 95%. And this is a very strong assumption, but that's what I've observed so far on just doing stuff like this. And it's cheap. If you want to go from the 95% to 100%, they do stuff like this when you're like, okay, I will also optimize the model. I want to have some supervised data and do stuff like that. But for the 95% use case, this is super cheap. This is the way to go. That's what I pay. Yeah.
So, how exactly you decide on a projective where you have to like,
Miss Colare
PCs? How exactly do you decide on an objective with use optimize or do assess? Like, what is an optimal consecution, optimal?
Yeah.
Seems rather vague.
Totally with you. I think, therefore, if you look at, so the paper that we have that's now on archive, doesn't even have like a formalization section. For the neuros part, we decided to go into detail about, okay, what even is an optimal constitution? And that, because we understood that, hey, talking about an optimal constitution being, let's say, it's to understand or like auditable or transferable is super difficult, right? Because then we're talking in the natural language speak doesn't need much. So for the unit submission, we went like always in for the verifiable metric. So we just say, hey, an optimal constitution is the one that gives you this super high score on this metric. It could be little hard to audit or have some let's say big tokens, but we just like abstract it out of now because we feel it's easy to formalize. But if you like ask me in person, I'd say apart from the metric, you also need to have a common MBZUAI. But I mean that's great. So as far as the formalization, we won't do that. We don't have any. This the metric.
Also, I think you can take one.
Okay.
I think
Yes, come on.
yes. I had a question. So once you like learn this sort of global constitution, it's plus the general training set at runtime, can you add like additional research?
Sure, you bit, but then you have to evaluate again, right? So if I were to do something like that, I'll essentially go back to my agent. So let's say this is your prod agent, right? That's the annotator that you have into production, and you will like change the prompt. I just have max again from that step onwards because I want to like say ensure that either this is like equivalent is performance to my existing constitution or it improves it. But I won't go to prod without like running Mac once more ahead. But watching let is fine. We do that all the time. Anything else? Always said like last one.
Oh, yep, I think that got so. All right, thank you so much for show.
Thank you.
But I think you're in Thailand with this to what comment, right?
Yeah, we came for the other one though. So for YC, we're doing the diffusion one. That's the iClear paper. But these work together. So you want to do Mac because I can just relevant to what you guys do. So I do this.